All right, good afternoon, everybody. This is a TI-sponsored project. It is ultrasonic object detection. Allow me to introduce the team. I'm Nick. I worked alongside Jonathan, Veer, Rudy, and Hector. TI currently is in the market for a cheap alternative to laser detection or using infrared light for object detection. And they are specifically concerned about object detection using ultrasound. So the purpose of this project is to increase the utility of an existing TI library that to incorporate the functionality to address the adjacent markets for standalone air conditioners, occupancy sensors, and garage door sensors. Our goal for this project was to detect the relative location of objects up to 13 feet away from the sensor with a reasonably small margin of error.
Here is the overview for capture, and in the last semester we switched the functionality of transducer between transmitting and receiving. This semester we dedicated one pin as transmitting and one pin as receiving. This allowed us to add additional transmitter to send out a strong signal and receive back strong capture. In addition to that, we also overcome the library limitation that increased our capture duration for which we needed to stronger, quicker capture time, as well as simplified our algorithm for object detection.
I'll discuss the case design of the project. We use SolidWorks to design and 3D print the model from previous semester. The transistors in the case are 8 inches apart because we found that this setting gave us the most reasonable measurements for the object distance and angle. The lid slides on and off for the easier access to the components inside the case. And having this case allowed us to easily experiment with the application and speed up our development process.
I would go over data manipulation. Last semester we used offline signal processing through a tedious procedure of capturing data and then migrating it from the application into MATLAB. We then translated that offline application in MATLAB into embedded C code to allow the procedure to be streamlined in the onboard application. And we also developed the user interface to print out the captured distance and angle measurements in real time.
To conclude, this semester we transitioned over to real-time calculation onto the board itself. We modified our prototype to include 2 pairs of transducers, each having 3 sets of 2 transmitters and 1 dedicated receiver. This improved our signal, increased our accuracy, and doubled our range of detection. As you can see by the graph above, or to the side, our margin of error is relatively low, seen by the dashed lines. We met TI's criteria, and with more optimization and refinements, the application will be ready for production.
I'd like to open the floor to any questions.
So, just to understand, right, so you say it can detect an object 13 feet away, so just assume that you have the garage, so do you have like 2 ends of the garage, you have a sensor talking to each other, is that how you're doing it? Like,
Currently we have it all in one casing. So it's just you would replace, right now there's a laser pointer and a receiver. You would replace that and just put a box on one side of the garage.
just one side?
Yes,
Or if it's a double garage, you'd do both sides.
probably, if it's too long and it's like a 25-foot garage or something, yeah.
Was TI happy?
Yes, we met their criteria and we were able to use the hardware that they provided us to build on their application and add the functionality of multiplexing transducers and producing an angle using ultrasound.
Is the sound bouncing off the garage door, either wood or metal? Is that the idea? I mean, are you at the side of the garage door, so you have to wait till it comes down and the ultrasonic can hit that?
So to address that, you're talking about the actual garage door that's coming down, right?
Yeah. What are you detecting about that? Are you detecting its actual position, or if you're are you at the side of the garage door? Is that where you're at?
Are you detecting a child in the way?
Yeah.
Child
Yeah.
anyway.
Okay. You're looking for a child in the way.
Yes,
Okay.
and so right now we're using transducers that emit a signal in a cone and receive a signal in a cone.
Okay.
And to make sure that it only is in one plane, we have
Okay.
columnizers that stop the signal from emitting and receiving from more directions.
Okay,
So
so
this
you-
would almost be impossible to
hit the button, garage door comes down, and try to jump your silly sensor
Yes.
to get out.
Yeah, you can't get it. Won't be able to fake it out anymore.
Yeah, I don't want one. What kind of accuracy in terms of angle and position detection were you able to achieve?
It's, so we
About
actually
less-
have two dashed lines on the graph there. One of them, I believe it's the red one, is the angle accuracy, and the blue one is the distance accuracy.
How do you tell it's not the garage door itself you're detecting? I mean, if it's coming down and you're looking at it, how do you know it's not a kid but a garage door?
Well,
Is-
I'm sorry.
The transmitter, the angle of transmitter is limited to an object in front of the garage door.
In front of the door.
In front of the
Right.
garage.
If you stand right underneath the door, will it still detect it though? I mean, if I'm right underneath the door, will it stop it? Or do I have to be in, I mean, to me, it's like you're looking at the same place the garage door is, so how do you know it's a kid or a garage door?
So if you're right under the garage door, it would detect you if you passed in front of it,
Okay.
from the inside of the garage to the outside. If you passed the other way from the outside to the inside and stopped right before you were in the plane of detection, it wouldn't detect you, but to solve that problem, you could theoretically just put one on the outside too.
I mean,
Does that make sense?
kind of, but it seemed like to me that if you're looking for something, you're mostly looking for something that's right under the garage door, right? And if you're not detecting something right under the garage door, it's not very useful, right? So you have to think about, I mean, I can understand if you're standing in front of the garage door, but that doesn't help because the garage door won't hurt anybody anyway. So you got to figure out, to me, the problem is you got to figure out how to detect whether it's the garage door or a kid. You know, I'm not sure how you've done that. I'll be interesting to see.
So if I look at your block diagram, you have transducer 1 and transducer 2.
Yes.
The object is in the middle. How does that translate to your case design? Where is transducer 1 and 2 on the case design?
This is generally we created to show the flow of the signal.
Yes.
How to start from the microcontroller to the transducer and over there. On the case design, the transducer send the signal, and the object is going to be just in front of that signal. It's going to reflect it back to the sensor. So kind of from this angle to that way. So transducer is going to be right by the controller, send signal on object over there, reflect back to the.
Which one of those 6 devices are the transmitters and which are the receivers?
So there's 2 different pairs. On the top one is 1 pair of transducers. So there's 2 that are transmitting at all times, and 1 is receiving at all times.
Okay, in the top and same way on the bottom.
Yes.
Yes. and
There's
just
2 on the
two
top
different-
transmitters and 1 receiver on the top, and 2 transmitters on the bottom and 1 receiver. Okay.
Yes.
All right.
Okay.